going on, guys? This is Dan here, and I'm going to be showing you my project WaveView. You see, I'm recording on my phone here just because I wanted to show the real-time graphics without any latency, and my computer is not too hot with, well, recording itself. So let me go through how it works, and then I'll run an example. But let me give you a little preview of how it works first. Here's an example of it running right now. All right, so what's going on here? Basically, we're taking a WAV file, an audio file, as an argument, and we're passing it to a couple of our objects. So our main object is going to be the engine. That's our graphics engine. But what we're passing to it is something called an audio data object. And I've created an audio data object, and that handles our file, and it turns this sound into stuff that we can work with and visualize and do some math with. And so basically what we're doing is we're taking our WAV file and we're using a library called drwav, and we're going to turn it into a bunch of samples. And these samples are actually floating point numbers, and they represent a given point in time in the sample or in the audio file. And so we're turning this audio into numbers, and we can use these numbers to play the audio back through the speakers. And we can also use this to get some information by doing some math with it. So what we're going to do is we're going to take a look at the pre-process function. And so we're going to take all of these samples, these points in time in our audio, we're going to break them up into chunks, and we're going to call them frames. And so each frame, we're going to have them overlap by about 50%. So they're a smooth transition. They're not very, discrete. And we're going to apply some math functions. We're going to do something called a Hahn window, which kind of continues to smooth them out and make it a gradual change in between these frames. And then we're going to apply a fast Fourier transform. And what does the fast Fourier transform do? It's going to tell us all of the different frequencies at a given point in time. So in a sample, how do we know what's the magnitude of the bass at a given time? Well, every frequency between 0 and 100 hertz, let's call that bass. How strong is it? How loud is the bass at this particular point in time? Well, the fast Fourier transform is going to tell us. So it's going to tell us that for every single frequency in just a sample. We don't need to know every frequency, so we can categorize them. Let's make 7 or so bins. I think that's what I have right now. So we're going to create a couple bins, and we're going to say, well, if it's below a certain threshold, we'll put it in this bin. But if it exceeds that threshold, we'll put it in another bin. So we can organize each sample into a set of however many you want. I think I specified 7 values. So let's say at frame, 2 minutes and 30 seconds, the bass has a magnitude of 100.4, while the treble has a magnitude of 200. And so we can use these floating point numbers to sort of compare the balance between the various EQ levels. And so what we're going to end up with after running our pre-process is an array of arrays. Each array in the greater array is going to represent a frame. And in each frame, we're going to have bins representing each category that we've specified. And feel free to change the categories. I had my program scale with however many categories you want and whatever value you want to assign these categories. So if you really want to know only the amount of frequencies that exceed 10,000 hertz, you can do that. You can have one single bar, but you can also have 75 bars. I put 7 because I think that's visually appealing. Playback, that's another object I've created. It's just going to take these decoded floating point numbers that represent the WAV file, and it's going to play it back. It's going to look for a device on the computer, and then if it finds one, it's going to repeatedly call this audio callback. All it's going to do is create a buffer of a bunch of audio samples, feed those numbers into the buffer, and send it on out to your speakers or your headphones. And for this, we're going to use a library called RT Audio. They're really good at doing some digital to analog conversion, turning these numbers into the real sound. So lastly, before I show you another demonstration, I'll show you how we update our graphics in sync with our audio playback. So our update function here is just going to update some values before we actually render them using OpenGL. And so before we render, we're going to ask our audio playback, hey, how many samples have you played to the speakers? You know, how many samples have you played? And we're going to take that number and we're going to then ask our audio data object, hey, what are the frequencies at this given frame? We know how many samples we've played, so we can take that number and figure out how many frames have occurred. So we can find that frame in our frequency history array that we've created. And then for each bin or category of frequencies, we can, change or scale up a bar on a bar graph for each frame and for each frequency. So then eventually we'll be able to visualize in real time the bass, the middles, the trebles, all of that for every frame. And there is 100 frames in a second, so it looks like a very smooth transition. And so this happens, and then we're going to render, and that's just going to present everything to the screen in the window. So it should happen with 0 latency, and I think it looks pretty cool. So let's play that one more time just to show you. As you can see, it actually takes maybe a second, maybe a half second to do all of the computations beforehand. It is overhead. This is about a 2.5 minute song, and it takes about, 3/4 of a second to process everything. But once it's all processed, it's actually in real time. All right, that's one. And just to show you a different one, let's try this very basic audio file right here. It's about 30 seconds. Maybe not as interesting as the one before it, but nonetheless. There we go. That's my WaveView project. Thank you for watching, and see you next time.